Okay, today we're going to talk about scientific notation. Scientific notation is used to write very small numbers and very large numbers.
So let's take a look at this example. We have 7.9 times 10 to the 5th power. In order to convert from scientific notation to standard notation, we're going to look at our exponent here, which is 5, and we're simply going to move our decimal point over 5 places to the right because it's positive. So our decimal was initially between the 7 and the 9, and we're counting over 1, 2, 3, 4, 5. The important thing to remember is our first number here is always going to be greater than or equal to 1, but it's going to be less than 10. So there's not going to be any more than one digit to the left of the decimal point, but you can have as many numbers as you want to the right of the decimal point. The important thing to remember is the second number will always have a base of 10, and then you'll have an exponent. A common error that you want to avoid is actually putting the base 10 first.
When you're writing in scientific notation, the second number, that is a power of 10, can have a negative exponent or a positive exponent. The exponent will tell you which way to move the decimal point, either to the right or to the left. If it's a negative exponent, you move the decimal point to the left. So in this example, the decimal point would move to the left 4 places. If it's a positive exponent, the decimal point moves to the right. So in this example, we would move the decimal point 4 places to the right. For these examples, we're going to convert from scientific notation to standard notation. So look at the exponent first. It's negative, so we're going to move to the left 4 places. The decimal point started between the 7 and the 9, so we're going to go to the left 1, 2, 3, 4. So now it is written in standard form. In the second example, our exponent is positive, which means we move to the right 4 places. So we started here, and we're going to the right 1, 2, 3, 4.
Now let's take a look at an example of converting from standard notation to scientific notation. The first thing you need to do is move the decimal point between the 6 and the 4 because we want a number greater than or equal to 1 but less than 10. So how many places do we need to move this decimal point from this location to this location? Well, the answer is 4. However, our exponent's not 4 because that's actually multiplying by a really large number. We want to multiply by a really small number, so it's actually negative 4. So if you remember from earlier, if you move the decimal point over to the right, it's a negative exponent. Let's look at our second example. We have 589 million. So in order to convert that to scientific notation, I'm going to move my decimal point between the 5 and the 8 because that first number, again, needs to be greater than or equal to 1 but less than 10. I'm going to multiply by 10, and then I have to ask myself, how many bunny hops do I need to get from this location over to this location? Now the combos will actually do you some good here because it's all multiples of 3. So 3, 6, and then I'm adding 7, 8. So here we've multiplied by power of 8.
Okay, the important things to remember for this lesson is that the first number is greater than or equal to 1, but less than 10. And the second number is always a power of 10. And if the exponent is positive, you move the decimal point to the right. And if the exponent is negative, the decimal point goes to the left. Now here are some problems to try on your own. For the first two, you need to evaluate from scientific notation to standard notation, and for the second two, you're going to go from standard notation to scientific notation.